Hi everyone. Today we're talking about linear correlation. Specifically what we're going to be doing is we're going to use technology, specifically the linear regression t-test on the TI-84, to evaluate a claim made about linear correlation between two variables. So what we're going to do is we're going to look at an example. One of the things I want to do is teach you how to create a scatter plot. You see a lot of questions in the homework on this section that ask you for a scatter plot, so I want to show you that. We're going to find R, which is the linear correlation coefficient, and we're going to use a hypothesis test and the p-value method to determine if there is correlation. So what exactly is correlation? What does that mean? Well, the correlation coefficient is R, and that tells us how well paired sample data fit a straight line. So if R is equal to 1 or if R is equal to -1, then the paired data fit a straight line perfectly. So the closer R is to 1 or -1, the more closely that the data fit a straight line. If R is equal to 0, then the data doesn't fit a straight line at all, and it is not correlated. So this correlation coefficient R is always going to be between -1 and 1. The closer it is to -1 or the closer it is to 1, the more, the better the paired data is going to fit a straight line. And the closer it is to the middle of these two endpoints, or if it's at 0, then the paired data is not linear correlated. We're going to be using the p-value method that we have used in several of the previous sections. And you'll remember that what we're going to evaluate is we're going to be using the calculator to calculate that p-value. And if p is greater than alpha, then that means if p is high, null must fly, and then we will fail to reject the null hypothesis. If p is low, or if p is less than alpha, if p is low, null must go, then we will reject the null hypothesis. So let's look at a specific example. So first of all, this is about crickets and temperature. So listed below are the number of chirps in 1 minute and the corresponding temperature in degrees Fahrenheit. Is there sufficient evidence to conclude that there is a linear correlation between the number of chirps in 1 minute and the temperature? So can you use the number of chirps from a cricket to predict what the temperature is going to be? So what we're going to do is use a significance level of alpha is equal to 0.05. First thing I want to do is show you how to create a scatter plot of this information. So to create this scatter plot, I've done it already and it's here, but I'll show you how to do it on your calculator. So first what you're going to want to do is you're going to want to enter the data. So I'm going to edit, and in list 1, I put the first row of values, which is the chirps per minute. And in L2, I put the temperature. It doesn't really matter if you put temperature first and then the chirps. That doesn't matter. But what does matter is that these values have to be paired. So you'll see 882 has to be across from 69.7, etc. as you go down the line. These data have to be paired. Okay, so I put the chirps in list 1. I put the temperature in list 2. Now, to create the stat plot, you're going to press second and stat plot, and you're going to have to turn one of the plots on. So if you press enter, you can toggle between on and off. I turned this on. Then you'll notice that I wanted it to draw this graph with dots, and I told it to use this square, and it's doing it in blue. Some calculators don't have that feature. So then what I want to do is I have to change my window. So I'm going to press window, and you'll notice I put these values in here. Now, how did I determine that I wanted to start at 500? So what I looked at was this list 1, and the lowest temperature was 860, or I'm sorry, the lowest number of chirps per minute was 864. I just went down to 500. The highest was 1200. I went up to 1300. And then I did the same thing with these values, which are essentially the Y values. So the chirps is X in my example, and the temperature is Y. And the smallest temperature was 69.7, and the largest was 93.3. So I went from 65 to 95. Once I press graph, you'll see the graph. This line here, let me clear that out of there for you. So you'll see that's the graph that is on this screen. So there's the scatter plot. You're going to be asked to do that in the homework, so I wanted to make sure you knew how to do that. Okay, so now let's use that hypothesis test to answer this question about whether or not there is linear correlation between these two variables. So we're going to have to set up the hypothesis test. We already did that. We entered the data in list 1 and list 2. If you haven't done that already, go ahead and do that in your calculator. And when we set up this hypothesis test, we're going to use this new variable, which we're going to be calling rho. And rho is used to represent the population correlation coefficient, R. Remember, we used sigma and S to talk about the population standard deviation would be sigma, and the sample standard deviation would be S. Remember those terms? So here in this section, the population correlation coefficient is rho. It looks like a P, but it's not pronounced P, it's pronounced rho. It's the Greek letter. And that's the population correlation coefficient, and the sample correlation coefficient is R. So when we set up our hypothesis test, our null hypothesis is going to be that rho is equal to 0. So remember, the null hypothesis is always an equation. So if rho is equal to 0, then there is no linear correlation. We are testing the claim that there is linear correlation. So that's our alternate hypothesis, H1, and that's that rho is not equal to 0. That's our original claim, that there is linear correlation. This is going to be a two-tailed test because of the not equal sign. And I want you to remember that the level of significance was 0.05. Okay, so we're going to do this on our calculator. We're going to be using, once you put this information in here, we're going to be using the linear regression t-test. So go to Stat, toggle over to the Tests menu, and scroll down using the down arrow until you see linear regression t-test. Our X list, remember, was list 1. Our Y list is list 2. And we are doing this two-tailed test. Remember, the alternate hypothesis is that rho is not equal to 0. Rho is not equal to 0. I had the calculator store the regression equation in Y1. This is going to come handy in the next section. I'll show you how to do that here because it's there. But you press vars, and you're going to choose Y variables, and you're going to choose to put it in Y1. We're going to be doing that in the next section, not here. And then we'll press calculate. I put this information on the next screen. So, actually, the next screen. So we get a test statistic here of 4.399 when I round it to 3 decimal places. The test statistic is the t. Remember, this is the t distribution. Our p-value is 0.0046 rounded to 4 decimal places. Now you won't see the correlation coefficient R on this screen. You need to scroll down until it appears. So the correlation coefficient is 0.874 rounded to 3 decimal places. Okay, remember we're using the p-value method. So our p-value is 0.0046. So since p is less than alpha, since 0.0046 is less than 0.05, we are going to reject the null hypothesis. If P is low, null must go. So the conclusion is that there is sufficient evidence to support the claim that there is a linear correlation between cricket chirps per minute and the temperatures in degrees Fahrenheit. Okay, good luck.